Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0139, signifies a slow response from the secondary heated oxygen sensor, HO2S, which is also known as Sensor 2, in Honda CRV models from 2011 to 2016. The secondary HO2S is a critical component in the vehicle's emissions control system, located in the exhaust system after the catalytic converter. Its primary role is to monitor the oxygen levels in the exhaust gases, which helps the engine control module, ECM, to adjust the air-fuel mixture for optimal combustion efficiency. When the sensor fails to respond in a timely manner, it can lead to increased emissions and decreased fuel efficiency. This issue may trigger the check engine light, indicating that further diagnostic checks are necessary. It is essential to address this code promptly to ensure the vehicle operates efficiently and within environmental standards. The error indicated by the DTC P0139 refers to the secondary HO2S exhibiting a slow response time. This sensor is situated in the exhaust system, specifically installed downstream of the catalytic converter. Its function is to measure residual oxygen levels after the catalytic converter has processed the exhaust gases. By doing so, it provides vital feedback to the ECM, allowing it to optimize the air-fuel mixture. If the secondary HO2S fails to respond quickly, it can result in inefficient combustion and increased pollutant emissions. Additionally, since the secondary HO2S is downstream, any issues in the exhaust system, such as leaks, can influence its performance and may falsely trigger this code. Therefore, identifying the exact location and understanding the role of this sensor is crucial for effective troubleshooting. Several factors may contribute to the triggering of the DTC P0139, indicating a slow response from the secondary HO2S. One major cause can be exhaust system leaks, as any breach can disrupt the flow and composition of exhaust gases reaching the sensor, leading to inaccurate readouts. Another potential culprit is damaged wiring or connectors leading to the secondary HO2S, which may cause intermittent signals or complete sensor failure. Moreover, a faulty secondary HO2S itself can directly result in slow response times, preventing the sensor from providing timely or accurate information to the PCM, Powertrain Control Module. Proper diagnosis must include an examination of these components to identify the root cause of this DTC effectively. Failure to address these issues can result in further performance degradation and potential long-term damage to the vehicle's engine and exhaust systems. The symptoms associated with DTC P0139 may include an illuminated check engine light, which serves as an indicator that the vehicle's onboard diagnostics have detected an issue requiring attention. Increased emissions may also occur as a result of a faulty secondary HO2S, leading to potential failures in emissions testing and contributing to environmental pollution. Moreover, poor fuel efficiency is another common symptom that drivers may experience. This inefficiency can arise when the engine does not receive accurate data for optimal air-fuel mixture adjustments, resulting in a less effective combustion process. Additionally, the vehicle may present other performance issues, such as rough idling or decreased acceleration, highlighting the importance of timely diagnostics and repairs to prevent further complications. For troubleshooting the DTC P0139, the first step involves ensuring the ignition switch is turned to the on position, or second position. This action powers the vehicle's electronics without starting the engine. Next, use the HDS, or Honda Diagnostic System, to clear any existing DTCs, including P0139. This process resets the system's codes, and allows the technician to gather fresh data during the diagnostic process. Following this, start the engine and maintain an engine speed of 3,000 RPM without a load, in either the park or neutral position, until the radiator fan activates. This step ensures that the engine reaches an optimal operating temperature and allows the whole test system to calibrate. It's crucial to systematically follow these procedures to ensure accurate diagnosis and verification of any faults present. Continuing with the troubleshooting for DTC P0139, the next step involves a controlled test drive of the vehicle. During this drive, ensure the engine coolant temperature, as measured by the ECT, engine coolant temperature sensor, exceeds 158 degrees Fahrenheit or 70 Celsius. This temperature threshold is necessary for accurately assessing the sensor's performance under typical operating conditions. While driving, maintain a steady speed between 55 to 75 miles per hour or 90 to 120 kilometers per hour for a duration of 1 minute. This stable speed allows for consistent readings from the secondary HO2S. Once the minute is complete, decelerate the vehicle while fully closing the throttle for 10 seconds. This process enables the technician to monitor changes in the exhaust composition reaching the sensor, providing pertinent data for further diagnosis of the slow response issue. After completing the controlled test drive, the next step in troubleshooting DTC P0139 is to monitor the onboard diagnostics (OBD) status using the Honda Diagnostic System (HDS). This tool provides real-time data regarding various vehicle functions, including the status of the secondary HO2S. If the HDS indicates a failed status for DTC P0139, this confirms that the slow response issue is replicated in a controlled environment and necessitates the replacement of the secondary HO2S. Conversely, if the status shows passed, it implies that the system holds no current faults. However, if it displays executing, continued driving may be needed until a definitive result is available. It is essential to regularly check the OBD status to ensure proper diagnostics, as intermittent failures may not appear during preliminary testing, but can surface later during normal vehicle operation. For effective repair verification concerning DTC P0139, begin by turning the ignition switch to the lock position to ensure safety during the reassembly process. Following this, all connectors involved in the secondary HO2S and the PCM must be reconnected securely to ensure proper electrical communication. After reassembling, turn the ignition back to on 2. The next step is to reset the PCM using the HDS, which is vital for clearing any stored DTCs and allowing the modules to relearn optimal functional parameters after repairs. Once the PCM is reset, execute the PCM idle learn procedure to recalibrate the system. Finally, similar to the preceding steps, run the engine while holding it at 3,000 RPM until the radiator fan engages, before conducting another test drive. Under the previously specified conditions, this thorough approach provides a complete overview of the secondary HO2S performance post-repair. After completing the repair verification steps associated with DTC P0139, the final verification must involve a comprehensive check of the OBD status once again. This step is crucial in confirming whether the DTC has been successfully resolved and whether the secondary HO2S is functioning as intended post-repair. The HDS should indicate a passed status, demonstrating that the issue with the slow response has been addressed effectively. If it still shows failed or presents any additional pending DTCs, further investigation is warranted to ensure that no other underlying issues are present. Once the past status is confirmed and no other codes appear, the troubleshooting process for DTC P0139 can be considered complete. This careful approach to verification helps ensure that both the repairs made and the overall vehicle integrity are intact. To prevent future occurrences of DTC P0139, certain preventive maintenance practices are recommended. One effective measure is to regularly inspect the exhaust system for any signs of leaks or damage, as even minor breaches can significantly impact the performance of the secondary HO2S. It is also advisable to routinely check the condition and integrity of electrical connectors associated with the HO2S and the PCM, ensuring they are free of corrosion or wear. Another critical aspect is ensuring that the vehicle's software is updated to the latest versions, as manufacturers often release updates that enhance various systems' performance, including the emissions control functions. By implementing these preventive measures, vehicle owners can help enhance the longevity of their Honda CRV and minimize the chances of encountering similar DTCs in the future. In conclusion, the DTC P0139 signifies a slow response from the secondary HO2S, which is crucial for monitoring exhaust emissions in the Honda CRV models from 2011 to 2016. Thorough understanding of the troubleshooting steps is essential in diagnosing this issue effectively. By following a systematic approach, including detailed checks of the exhaust system, wiring integrity, and the HDS readings, technicians can accurately determine the root cause and perform necessary repairs. Furthermore, implementing regular maintenance practices can help prevent future occurrences of similar issues, ensuring that the vehicle continues to operate efficiently and within emission standards. Overall, proactive measures and thorough diagnostics are key to maintaining a healthy exhaust and emission system in these Honda CRV models. Please like and subscribe to the channel. See you next time.